I'll do it. Meow, meow, meow. Welcome to biology. We're learning tonicity today. Let's go. How's that? Is that like a podcast? Is that podcast worthy? You think I'll get more hits on YouTube once I do that little intro sound?
That was great.
Thank you. Thank you. My brother has a podcast.
I felt so
That's what he
bad.
does.
Yesterday I was checking Mr. Thompson's, he posted a video, and it only had one like. And I was like, I'm gonna like it now.
You guys, I hope no one sees my YouTube videos. Holy crap. That would be really embarrassing.
What are they just talking about science?
West gives you a shout out on YouTube.
That would be great. That'd be great. Okay. Alright, so the concept that I'm teaching you today is tonicity. The reason it's called tonicity is because it's based on the terms that we just defined on the other side of the paper. Hypertonic, hypotonic, and isotonic. That's why we call it tonicity, okay? So knowing what will happen to cells based on the concentration of water and the concentration of solutes is what we're determining. So we're going to go through several different scenarios, okay? So here we have a beaker, and here we have a cell, okay? So in this situation, the cell is 90% water. So let's go ahead and write that or type it. You should be able to type in that little box. So 90% water, okay? You don't have to subscript the 2 if you're typing, but there is a way to do that by going to font, scrolling over, and then it drops down subscript 2 if you want to make it lovely, okay? So the cell is 90% water, and the environment, or the outside of the cell, is 20% water. I'm going to do H2O because for some reason those 3 units are quicker than writing water. Now we also want to calculate the solute, okay? So what could solutes be? Can you guys list examples of solutes so when we say solute, we know what we're talking about? Salt, sugar, whatever's dissolved in the water, right? Yeah, glucose, okay. So if there's 10% water, how much solute? You guys yell out your mathematical calculations. Did I yell out the answer? Did I tell you the answer? Sometimes my mouth doesn't listen to my brain. Yes, 10 is the correct answer. Good job. Me. Quiet. Students were supposed to yell that out. All right. If there's 20% water on the outside, how much solute would there be? Thanks. Teaching one person. Come on, guys. Yell out your guesses.
I'm trying to type this.
Oh, am I going too fast because you're typing?
I was just spelling solute.
Okay, I'll go slower. Tell me to go slower.
The E was disconnected.
All right, now we add arrows. Question.
What is that 10% for again?
Yes, good question. So 90 and 10 equals 100, right? So that's where they got the 10 from. Same thing with the 80 here. 20 minus 100 equals 80. So we have to have 100% of the solution. So if we're simplifying life so that we can understand these concepts of tonicity. Now we're making arrows solely for the direction that water would move because we don't know that solute can move into or out of the cell because some solutes might be too big, okay? So we're just talking about what's going to happen with the water. So if you would please, either with your computer, Chromebooks, add an arrow either into or out of the cell or with your writing utensil if you're doing it on paper. Can everyone yell which way the water would go? Yell out into or out of. It's okay if you're wrong, yell something.
Wow.
Yes, because water moves through osmosis from an area of high to low. There we go, okay? Did you guys make a digital arrow? Did you?
No, I didn't know.
Oh, I did a digital arrow.
Yay, digital arrows. Okay, let's try the next one. You get the idea. The cell is 50% water. And the environment is 50% water. How much solute would the cell have? Yell out your guess. I told you the math was easy. You were scared, weren't you? You're not scared of math. Who's scared of math? Nobody.
I was shivering.
No, you're not, Andrew. You've got math. All right, how much solute do you have in the environment? Yell out your guess.
50.
It's even. She noticed that it's even.
Wait.
So what happens to the net movement of water?
Does it stay the same? Does it like move?
Okay, that's what I want to talk about because this is balanced. right? You guys noticed it's balanced. Do molecules ever freeze and not move? No. So that's why I said net movement. So there's no overall net flow in one direction. So we call that equilibrium, but I want you to add a word to equilibrium.
Why is it doing this all of a sudden?
Maybe you just need to write it out. Is it not working
No,
for you?
it's not that. It's that for some reason in the second one in the text box, it's only letting me put like 2 letters instead of up to 4 before it goes down, and it like cuts the word
because
off.
make it font size 7. Highlight it and make it font size 7. And then it should all fit pretty much better. It's almost more work to figure out how to do it digitally than if we were just actually writing, but anyway.
I'm gonna do that with
So what I want you guys to write is I want you to write dynamic equilibrium, okay? The reason we say that is because that's explaining that there's no net movement of water in one direction or other, but molecules are still moving, right? I don't want you to think that everything freezes in 50-50, right? You know, they're still bumping around, they're still maybe moving through the membrane, but they're not flowing from high to low, okay? So what should we do for the arrow? Make a super tiny arrow that just shows that there's movement in both directions, okay? But there's no net flow. There's not a big arrow moving into or out of the cell, okay? We're going to assign names to all of these at the end. So think about whether they are hypertonic, hypotonic, or isotonic. Question?
So for like the dynamic equilibrium, is water coming in and out at the same time?
Yeah, it's just meaning that water never freezes. Because when we do this and we talk about water moving out, water moving in, once it's balanced, students tend to think, because they think like a math problem, that everything freezes.
So it's just
Molecules don't.
Rate?
Yes, same rate in, same rate out. We're just moving around the way they normally would, okay? There's no overall change. And that has a name, which we'll get to in a second. Maybe you know it already, but we'll write it down in a second. All right, let's do the next one. If you haven't already moved on to the next one, 40% water on the inside of the cell. And on the outside of the cell, we have 75% water. Let's do the math. On the inside of the cell, how much solute would we have?
60.
Yep. And on the outside of the cell, how much solute would we have? 55. Net movement of the water into or out of the cell. Yell out your guess. It's okay if you're wrong. Into. Let's make a nice big arrow and move it into the cell. There should be a little box for you to add an arrow on that digital document. Okay. Now we're going to change things up a little bit. It might seem like we're doing the same thing 3 times, but we're not. Notice that I am giving you guys different things. I start off by telling you what's the solute is in this one, okay? So for the cell, we have 85% solute. 85, I meant to write, not 80. So how much water would we have? Yell out your guess. Now on the outside of the cell, we have 30% water. I think it helps to write it in the same place every time. How much solute? 70, you got the gist. Now, which direction would we see osmosis happening? Into or out of the cell? Everybody yell out your guess right now. Into. There's more water on the outside of the cell. So water moves through osmosis from an area of high concentration to low. There's a higher concentration of water on the outside of the cell, so it's going to move to the lower concentration of water on the inside of the cell. Now, let me add the words to this, to all these 4 together, and then I'm going to have you do the remaining 2 on your own. So don't go to the remaining 2 yet, okay? Let's look at the first beaker. It's a beaker, pretend, use your imagination. What would we say the solution is, and what would we say the cell is, okay? So we're going to identify both of them. We're not just going to say the solution. So we're going to specify. Is the cell hyper or hypotonic?
Hypo.
Let's go back to our definition on the back page so we can remember, because we're going to use these words. A hypotonic solution has more H2O, okay? So So hypo has more H2O. Everybody say that. Hypo has more H2O. One more time. Hypo has more H2O. One more time. That was a bit of a question, so you're like, okay. All right, hypo has more H2O. Remember that, okay? So then you'll remember both of them. Okay, so is the cell hypo or hypertonic? I want more than one person to yell out their guess. Go. The cell is hypotonic. But we also want to say what the solution is. What is the solution? Hyper. Because there's less water in the solution. Okay? All right. Dynamic equilibrium tells us we have what kind of tonicity? Everybody yell out their guess. Hyper, hypo, or isotonic? Yell out your guess for this one. This is isotonic. Okay? Squeeze that in there somehow. I don't know how you're going to do it digitally. I think I gave you a box up there. Are you still trying to do it digitally, guys? Is it working? Yay, technology. All right, next one. Let's separate the cell tonicity and the solution to this tonicity. So the cell, is that hyper or hypotonic? Yell out your guess. It's hyper because it's got less H2O, okay? The cell is hypertonic. Whereas the solution is, gotta be the opposite, right? Yeah, it's gotta be. Okay, can you finish the last three? So can you say what the cell is and what the environment is in for this one, because we didn't do that. And then can you do the last two on your own? I'm gonna wander around and help students that might need help, okay? Or just peek over your shoulder and be creeping on you. Makes it so much more fun. Ready for my close-up. Right. Yeah. Okay, kind of looks like everybody's almost done.
Almost.
Okay, let's discuss. If you're still working on it, that's fine. Let's go to this one right here, our first cell and beaker. So we said the movement of water would move into the cell. So what is the cell? Everybody yell out hyper or hypotonic or isotonic. The cell itself is hypertonic. And what about the solution? Yell that out. Everybody yell it out. It's gotta be hypo, yeah. Hypotonic. Good. Next one, this is a 6. Trust me that that's a 6. It's kind of messy, but that's a 6. So, you probably wrote in the numbers, right? We have 65% water if we have 25% solute. And if we have 25% water, we have 75% solute. Direction of water, yell out into or out of the cell. Yell out your guess. Everybody go. Out of. I think that was like 50% of you talking. Next time, let's try for a little bit more.
Oh, I was just putting in there.
So what would the cell be? Yell out hyper or hypo or isotonic. The cell is got more H2O, so it's hypo. The solution, hyper, yeah. Good. Last one, direction of water movement. Yell into or out of the cell. It's okay if you're wrong. Yell something now.
Into.
Yes, we've got a heck of a lot more water. There's going to be a large net movement of water into the cell. So what is the cell in this situation? Hyper or hypotonic? Hyper. Just think about a hyper person as taking in a lot of sugar, right? That's a lot of solute, right? There, I just thought of a really good memory aid. You're welcome.
That's not me.
Do you like that memory aid? A hypertonic solution would have a lot of solute, so that means a lot of sugar maybe. So if you have a lot of sugar, you're hyper. Okay, thanks. I need that positive reinforcement. Appreciate it.
Thank you.
So if the cell is hypertonic, the solution must be, everybody? Gotta be hypo. Got it. All right, so not so hard with the math. We did it. Let's go down and put this into a conceptual story. There's a fish here. What's this fish's name? Let's name this fish.
Fred.
Fred. Okay.
No, Nemo.
Okay, you can call the fish whatever you want to call it. Fred is like, I'm sick of this cold Michigan weather / coronavirus that I'm dealing with, so I'm gonna go on a vacation to Florida. So he jumps out of Lake Superior, walks on his little fish fins all the way down to Florida, and he's like, finally, I made it. Somehow he's not dead yet, because this is a fake story. And he jumps into the ocean in Florida. What would happen to Fred?
Because he doesn't know how to take in salt.
Right. So, yes. This is a true story, you guys. I saw it on the internet. All right. So draw a picture of what Fred would look like after he jumps into the ocean in Florida.
Oh, I was just filling him in.
You can do it in draw. I did it in draw.
Did you draw those fishies?
No, it's a Google image. I dropped in an image and I typed in outline of a fish.
Okay.
This is the one that I did in Google Draw. I did that with the computer.
Oh, that's really cute. I love that.
Thanks. Let's see if I can actually draw it better than my computer scribble. He's supposed to be shriveled. Did you get that from my?
Yep. But I just got here.
I'll make him a little more shrivelly.
Can I just try and
Oh,
like
and
copy
he's
him
sad.
except
That's a
his
bad
name?
vacation. All right. So let's just explain conceptually what would happen. So the cells of the fish would shrivel.
What?
You think it looks like a worm?
Yeah, my drawing skills are fantastic.
Well, write words so that you can understand what you were trying to explain. The cells of the fish would shrivel and the fish would die.
So if you walked all the way to Florida to die?
I know. It's a sad story.
I think you would have shriveled
It's
up
artistic.
before that.
In order to be artistic, you have to be sad. It's the definition.
Wait.
Artistic.
So you're telling me I have to be sad?
I'm kidding. Kidding. Sometimes people believe that. Like, as long as it's dark, then it's artistic. I don't believe that. I think happy things can be artistic.
No! This scribble disappeared.
Like my outfit. It's very artistic and happy.
What?
All right, next thing that happens.
No.
is Fred, before he jumped in the salt water, he was talking with Betty, a freshwater fish. And he was like, hey, how's the water? And she's like, oh, it's great. It's great. He's like, well, you know, I came from this place where the water's really cold, but there aren't very many people. And Betty's like, that sounds great. I'm going to go where you're from. So Betty jumps out of the water in Florida and walks up to Lake Superior. It was just like, yeah, that makes sense. She just gave me like the Gwen. She just nodded and she's like, yeah, that's a conceivable story. Sure. So this is a freshwater fish. This freshwater fish is going to jump into Lake Superior. Sorry, said it wrong. This saltwater fish is going to jump into Lake Superior, into freshwater. Okay? What would it do? Draw a picture of Betty.
He's gonna go.
She would die, right? What are we drawing here conceptually? The cells of the fish would swell, maybe burst, cause the fish to die. Cells swell.
How'd you make my fish very big?
This is a really dark story about fish.
I don't know what you're talking about.
Well, the moral of the story is don't put your saltwater tank fish into Lake Superior thinking that they would be free. That's not free now. Be free.
The scribble disappeared again.
Okay. Fish will die.
He's a big boy.
Okie dokie. So, remaining today is going over the Amoeba Sisters. Can you guys grab your, how much time do I have?
It's 51.
Okay, that's enough time. I can do it. I'll talk faster. Enough of the silly stories. Let's just get to the facts here, people. No more silliness. Amoeba Sisters, pull it out. I'm going to go over it. You're going to correct your answers. So pull it up digitally or whatever. Okay?
I got really confused for like a split second.
Amoeba Sisters, the thing that I checked yesterday,
Yeah.
that's what we're going over. Okay? Please tell me if I'm not clear. Okay. All right, so the first thing that you had to do, I'm just going to explain them, and then you're going to ask me questions if that works for you guys. Is that okay? Yep. Okay, because you did this already. So you needed to sketch the phospholipid bilayer, making sure to identify the polar heads and nonpolar tails. That is a chemistry term. When you think of polar, that is like water. Okay, you'll learn why water is polar when you take chemistry, but polar things are attracted to polar things. Water mixes with water, okay? Nonpolar things are like oil. They are repulsed by polar things. So they're going to move away, chemically speaking. So that is why this phospholipid bilayer arranges itself in that way. You don't need to know the chemistry behind that, but I think sometimes hearing that, even if you don't fully understand it, helps you understand why these little spheres of lipids are floating and staying the way that they are. It's because of chemical attraction and repulsion, okay? And that's another reason why certain things can pass through and certain things cannot. So you drew a little sketch, right? So what is simple diffusion? Simple diffusion moves from high to low. See if you put that in your answer. If not, add it. It is a type of passive transport. Did you write passive transport in there? Great. If you didn't, stick it in there. So small things can move. Oxygen, carbon dioxide. We put that on the other sheet. Just know that for our quiz. Or test, actually. Know that for our test on Friday. So either put it there or you put it that small molecules move through the cell membrane by passive transport, oxygen and carbon dioxide. We just put it here. Remember we did on question number 6 yesterday? So we wrote it down twice, so it's important to know. I'm going to post this key at the end of the day, so if you just want to listen and then look at it when you're filling out your review packet or studying, that's fine. You can just listen.
Because
if you don't want to fix your answers now, you can fix them later.
Like when you first posted it wasn't like a Google Doc, it was like some other thing at first that I could draw.
They send it to us as a PDF, so when I convert it to a doc, it moves things around. So it's a little bit better. Sometimes just to print these off, it makes it less confusing. So the statements that are true about simple diffusion is A, it's a form of passive transport. B, molecules travel with the concentration gradient. Remember, floating with the stream, down the stream, okay? Sometimes students get that wrong, so make sure that you put B in there as well. The other one that's true is that small molecules can pass through. Did you check all three? If you added another one, fix your answers. Looking at number 4, moving with the flow, we sometimes refer to that as moving down the concentration gradient. Did you draw more molecules on this side and less molecules on this side? Did you write the words high concentration here and low concentration here? If you did not, tweak your answers. Like I said, I'm going to add this key to Google Classroom so you can look at it again if you don't get everything written down, or if you just want to listen now. So I'm going a little fast so that we don't run out of time. Are endocytosis and exocytosis forms of passive or active transport? That's active. Think active requires energy, okay? So those are totally changing the shape of the cell membrane. So that's going to take energy. So certain things that are large might need to be brought into the cell. Give a scenario where a cell might perform exocytosis. Exo, exiting, pushing something out. So what would the cell push out? Waste, something that the cell's manufacturing. If it's the cell's job to make insulin, then it's going to make the insulin and push it out into the body where it might be needed. Okay? Make sure that you are aware. Write this down. There are 2 forms of the way a cell can take things in. It's more vocabulary to know. Endocytosis. Cells can take in food. If they take in food, it's called phagocytosis. If they take in fluids in bulk by surrounding them and bringing them in, that's called penocytosis. Can you guys say phagocytosis? Everybody try and pronounce it. Now try and pronounce penocytosis. Weird words, right? But those are both types of endocytosis. Please write those down, maybe in the margin on the bottom. Did anybody already have that in their answer? Probably not. So write it down the bottom, okay?
I don't think they said those exact.
I'm pretty sure they did, but maybe it was quick. I want you to know those. If they're not in the video, write them down, okay? When you're ready, flip your paper over so I know you're ready for the back. Again, this is going to be on Google Classroom at the end of the day. Checking your answers because we're running out of time. F as in frog for 8. S as in Sam for 9 and 10. A for 11. And F for 12. Okay? You got those great? If not, look at them later when I post the key. Here is what you were supposed to do. A lot of students struggle with this because this is the first lesson that I give you on facilitated diffusion. So you might need to add a couple things. Remember, facilitated diffusion is passive. So it should be moving from high to low concentration. Okay? So please either put in a bunch more molecules on this side versus this side, or write the words high to low concentration, making an arrow showing the direction of movement to the best of your ability. Okay? Again, I gave you points for completion on this, so as long as you know this stuff for the test, you're good. All right? So this is facilitated diffusion. It moves from high to low. I'm going to show you the other one. Okay, the other one is the opposite. So we're using a membrane protein here to pump things against their concentration gradient. So we're pumping things that are in low concentration to an area of high concentration. We might want to do this. Your neurons do this to send electrical charge. They build up ions to send an electrical impulse. This is how electricity gets sent in your neurons. The electricity are electrons. Electrons come from ions. Maybe too much chemistry for you to understand right now. Aren't you guys excited to learn chemistry? So all this stuff will make sense to you.
Oh yeah.
So much fun. So there are reasons why your cells might want to do that. Your neurons are an example. Okay? There might be other reasons. A cell might need something so that it can do its job. So just need to memorize for the quiz, for the test on Friday, that active transport happens from low to high through a protein channel. Okay? What questions do you guys have on that? Awesome. You can wipe down your desks. Remember, if you have your review done by tomorrow, you can check your answers with the key and begin to study. I have some fun study suggestions that I will offer for extra credit tomorrow. So, if you would like to take me up on an opportunity for extra credit, I will give you an option to do that tomorrow to help you get ready for your test on Friday.
This go by so fast.
Because it's so fun.
Remember, look, it's you at the piss with a mohawk.
I bet I can grab your wife.